Hi, my name is Xingyue Yang. I participated in the short program of the summer of 2014. I worked with Professor John Addison in the Material Science and Engineering department. I worked on a project involving high-pressure die-casting magnesium alloy. High-pressure die-casting magnesium alloys have a cooling rate far from equilibrium, so we want to know whether its microstructure is uniform across its geometry. Since microstructure is related to mechanical properties, quantitative characterization of microstructure can help us understand the solidification kinetics and predict its mechanical properties. Now, I can't wait to share with you my experience at shore. Let me first take you to a tour around my lab. So this is the part of the lab that I normally do my experiments in. I will give you more details on the equipment that I used. Whenever I get a new piece of material, I will first take it to the cutter and cut the material into small pieces. There are two cutters in the lab. The one on the right is used more frequently and is easier to use. The one on the left is older and more difficult to use, but it can cut materials faster. You press the power button and the blade begins to rotate at a very high speed, and in no time, a small piece is cut off from the material. After the material is cut into small pieces, I will mount each piece to make it easier to polish. I will place each piece in a solution consisting of resin and hardener in a ratio of 5:1. It will normally take up 8 hours for it to solidify, so I usually place the solution containing the specimen near the vent before I leave the lab and pick it up on the next day. With the mounted specimen, now it's time for polishing. This is a manual polisher. Grinding and polishing is separated in this machine, where grinding is on the left and polishing is on the right. Since magnesium alloys are very easy to oxidize with the presence of water, I normally use the manual polisher because I can detect oxidation more easily. With the manual polisher, if signs of oxidation are detected, I can just go to the previous step. While with the auto polisher, if oxidation is detected, I probably need to start over. To use it, just simply put the grinding paper or polishing pads on the metal plate. If water is needed, just press the button for water and it will come out from the black pipe. Then we turn on the machine and the metal plates along with the pads begin to rotate, and we press the specimen on the plate in order to polish. This is the auto polisher that I mentioned before. It's suitable for those alloys that are not so easily oxidized. I also work with aluminum alloy a little bit during the summer, so I also get to use the auto polisher. It does save a lot of manual work. Unlike magnesium alloys, aluminum alloys do not oxidize with water, so I can just set the conditions for polishing and pick it up when it's done. However, the auto polisher needs cleaning on each step, which is quite time-consuming. Well, I guess nothing's perfect. The well-polished specimens should have a look like this. It should have a smooth and shiny surface, just like a mirror. You could clearly see the reflection of your face on a well-polished specimen. After the specimens are polished, I will take it to the scanning electron microscope, also known as SEM, to look at the microstructure. On the left is the chamber where I load the specimen. There is also a EDX camera attached, which allows us to know the composition and orientation of a given structure. The microstructure of the specimen can be clearly seen on the software installed on the computer. We usually need to apply a layer of carbon coating on the specimen before we load it into SEM to make it electronically conductive. So I need to wash up the carbon coating after it's taken out of the SEM using this machine. I put the specimen in a flask containing ethanol and place it in the machine. The machine uses sound waves to clear out the carbon particles. After a short while, the solution turned black and the carbon particles are gone. So that's pretty much what I do for the summer. Shore is a fantastic program. I get to work with so many wonderful PhDs and I learn so much. I hope all of you enjoy your Shore experience as I do. Thank you very much.